In today's lesson, we're going to be talking about graphing rational functions. Okay, and so before we start graphing, I want to talk about what is the most basic that a rational function can get. Well, if you remember, the word rational means that we're talking about a fraction here. And so when we talk about a rational function, it's going to have a fraction in it. The basic rational function, or the most basic that the function can get, is called your parent function. And this particular function, the parent function, it comes in this form. It's y equals 1 over x. So notice there's our fraction, and our x is on the bottom of the fraction. So to be a rational function, your x has to be on the bottom of the fraction, okay? And I do want you to notice something. This is an inverse variation, which is what you have been talking about the past couple days. And so it kind of relates to what you've been talking about. The other way that they could write this is, instead of using the y, if you remember, y is the same thing as f of x. And so it could also be written as f of x equals 1 over x. But that is the basic form of these functions. And so we're going to work on graphing them today. So before we actually get to the different graphs that we will be working with, we're going to graph this function right here. So I've come up with a table of numbers that we're going to plug in. And remember, you could also graph this on the calculator and look at the table in the calculator. But we're going to plug these numbers in for x so that we can see some coordinates that we could graph, so we could see what this graph looks like. Okay. So when I plug in my -2 here, it'd be 1 over -2, which is -1/2. So that'd be the same thing as -0.5. I'll write it as -0.5. When I plug in -1, it'd be 1 over -1, which is just -1. When I plug in -1/2, it would be 1 over -1/2. So if you remember, when you're dividing by a fraction, because that would be on the bottom, you flip and multiply. So when I do that, I would actually end up getting -2. Okay, when I plug in my -1/2. When I plug in 0, it would technically be 1 over 0. And if you remember anything about having a 0 on the bottom of the fraction, that's an undefined number. So if you were looking at the table on your calculator, it's going to say that there's an error right here, because that is not a number that is defined. And so there will not be a value when you plug in 0. So either you'll see like a line showing that there's not a number there, or it'll give you an error. Okay, when we plug in 1/2, it'd be 1 over 1/2. So we multiply by the reciprocal like we did the other fraction, and we'd end up getting a 2. And then when we plug in the 1, it'd be 1 over 1, which is 1. When we plug in the 2, it'd be 1 over 2, which is 1/2, or 0.5. So from here, we're just going to graph those coordinates to see what this function looks like, which you're going to notice looks a little different than what you're used to. Okay, so let's see. I'm going to put some marks on my graph. So that would be like -1, -2, 1 and 2. Mark some up here. I think it just goes that far. All right, and then we're going to graph. So we got -2, -0.5. So -2 and -0.5 would be about halfway. So right there. Oh, -0.5. Sorry, it goes the other way. So -2, -0.5 would be about right there. And then -1, -1 would be right there. And then -1/2 and -2 would be about right there. Okay. And now, if you needed more coordinates, by all means, you can plug in more numbers for x to get more points. But this should actually give you an idea. What this function actually looks like if you graph it on this side is it's going to kind of curve, and then you'll notice as you go further and further this way, it actually gets really, really close to like the x-axis right here, but it actually never touches it. And same thing down here. It's going to get really close to that y-axis if you extended it without actually touching it. Okay, so that's what's happening on this side. Okay, So you'll notice the reason why I said this graph's a little different is because it actually has two parts to the graph, because I've only graphed these points so far. So now let's keep going. 0 doesn't have a value at it, okay, because remember, you'd have a 0 on the bottom of a fraction. Then we keep going. So 1/2 and 2. So 1/2 up to 2. Then 1 and 1, which is right here. And then we have 2 and then 1/2, which is right there. And so this kind of does the same thing, but on this side of it, okay? And so if we extended this graph this way, same thing. It's going to get really close to the x-axis without touching it. It's going to get really close to the y-axis here without touching it, all right? So this graph has what's called asymptotes in it, okay? It actually has two of them. And an asymptote is a line that the graph gets close to but never actually touches. And there's two of them here. You've got one right here, which is the x-axis. So the x-axis, which if you remember, is the same thing as the equation y equals 0, because it's a horizontal line going through the y-axis at 0. So that is what's called a horizontal asymptote. And horizontal, remember, goes left and right, because it is a line in your graph that when you've graphed it, it gets close to, but it never touches. And then it has another asymptote here, which is the y-axis, which if you remember, would be the line x equals 0, okay, because it touches the x-axis at 0 and nowhere else. And that would actually be a vertical asymptote in your graph, okay? And so all of these rational functions will have a vertical and a horizontal asymptote. And again, it's just the lines that your graph gets close to but never touches, all right? And so when we graph these other graphs in a minute, you're going to have to look out for those to be able to tell the equation of those lines, okay? But that is the basic graph of a rational function. It kind of curves on this side and gets really close to this line and that line on this side. And then same thing over here. It gets really close to these two lines, but kind of curves away from them. All right. So now that we kind of know how to graph it, we're going to start transforming those functions. Okay. So the two things we're going to work on is moving it left and right and moving it up and down. So if you remember when we did transformations before, if there's something happening with the x values, it's happening to the x part, then remember that number is going to move the graph left or right. And remember, it does the opposite of what it says. Okay, so you have to remember that part. So if there is a number being added or subtracted to the x part of your equation, it's going to move it left or right. Whereas if you have a number that is kind of not with the x, in other words, like it's outside of the function, the outside stuff, it's going to move it up or down. So that k will move it up or down, okay? And now with this, because you're moving it up or down or left or right, it's going to actually shift your asymptotes, okay? So if you're moving it left or right, it's going to move the vertical asymptote, and you'll see why in a minute. And if you're moving it up or down, it's going to move the horizontal asymptote, okay? So we're going to do an example so you can see how it shifts it, all right? So notice you still have the 1 over x, but now there's going to be stuff with it. So you just have to look at the stuff that's with it. All right, so let's look at the first example here. It says you've got f of x, which remember is the same thing as y, equals 1 over x plus 2, and then minus 1. So notice the 2 is with the x. So since it's a plus 2, remember if it's happening with the x, you do the opposite. So we're going to put a little reminder up here. Make sure you do the opposite of what it says. So since it's a plus 2, think it's with the x-axis goes left and right. We would think that it would move right 2, but the opposite of that would mean that it moves left 2, okay? And then this number up here, remember, it's like where the k is, it's either going to move it up or down. And so you're going to do exactly what it says. So if it's a minus 1, that means it's going to move down 1, okay? So When we graph it, if you remember the graph, the basic graph looks like this. So it's going to look like that in the end, but to kind of make it a little easier, instead of trying to move each of these points, which if you remember were like halfway between things, that would be a little harder. We're going to actually move the asymptotes, because if you remember, the asymptotes kind of cross in the middle of them, okay? So whenever I graph these, I am going to move the asymptotes and then graph or sketch the graph of it, okay? And so the asymptotes are going to be moved just how everything else will be moved. So we just discussed it's going to be moved left 2 and down 1. So if you remember, originally the asymptotes cross at the origin, which is the point 0, 0. So it's going to start at 0, 0, and then we're going to shift it however it's supposed to be shifted. So from here, if I'm supposed to move it left 2 and down 1, well, I'm going to start at 0, 0, which is where my original asymptotes would cross, and I'm going to move left 2, so left 2, and then down 1, and now that's where they would have moved to. So these are not actual lines in your graph, but I'm going to kind of dot some lines so that I can visualize what's going on. And then I'm going to sketch my graph according to acting like this is my new origin, okay? So act like this is like your X and Y axis, and then you'll graph it like normal. So if you remember, one key point that was here was like at 1, 1, and then it kind of got close to the asymptotes from there. And then another key point on this side of the graph would be like -1, 1. So I'm going to graph those points, and I'm going to sketch my graph from there, okay? So let me zoom in so you can see this graph a little bit better. From here, I'm going to go from my new origin, I guess. I'm going to go up 1 and right 1. So up, or actually it'd be really right 1 and up 1. So that would be where my new point is. And then I'm going to sketch it. Remember, you've got to sketch it so that it gets really close on each side without actually touching. And then down here, now my graph kind of ended, but I could go kind of label some points for myself, left 1 and down 1, and that would be where my other part of my graph is. So I'm going to end up running off of my paper here, but hopefully you can kind of see what it would look like. Okay, so all right, let's do another one since I kind of ran off my graph or my paper there, and that way you can see another one. Okay, so let's say this time we have f of x equals 1 over x minus 3 plus 2. All right, so figure out what's going on. All right, well, this one, it's a -3. So since it's with the x, we do the opposite of what it says. So a -3 would mean that it would actually move right 3. And then an up 2, well, that's not with the x. So you do what it says, and it's going to move it up or down. So that would be up 2, not 3. All right. So then I sketch my graph. And I'm going to see if I can fit it on my paper this time without running off. And I'm going to move my asymptotes right 3 and up 2. So right 3, 1, 2, 3, and up 2, 1, 2. And that would end up right there. So that's, remember, where your asymptotes move to. Okay, so I'm going to kind of draw those invisible lines so that I can see my graph. And then I'm going to sketch my graph from there. So remember, from this point, you graph each side of the graph. So you go right 1 and up 1. So that would be kind of where that part is. And you draw it so that it gets close to those lines without touching them. And then the other part, you would go left 1 and down 1. So left 1 and down 1 would be right there. And then you draw it so it gets close to your asymptotes without touching. Okay. Now, what we have not done yet is talked about the equations of your asymptotes. Okay. So notice this is your vertical asymptote. So you just have to tell the equation of it. And if it's a vertical line, that means it's touching the x-axis at one point. So to tell the equation of that one, you just put x equals, because it's touching the x-axis at one point, and then you tell where it touches the x-axis. So if you remember, it was moved right 3, so it's going to touch the x-axis at 3. So your vertical asymptote, which we could just put a VA for vertical asymptote, would be x equals 3. And then your horizontal asymptote, because it's touching the y-axis at one point, I'll put HS for horizontal asymptote, or HA. I don't know where the S came from. HA for horizontal asymptote would be y equals, and then you tell where it touches the y-axis, which would be y equals 2. Okay. So let's go back to this other problem and practice telling the vertical and the horizontal asymptote for those. Okay. So the vertical asymptote would be right here. And remember, vertical touches the x-axis at one point. So vertical, where does it touch the x-axis? At -2. So it's x equals -2 for the vertical asymptote. And then the horizontal asymptote would be, it touches the y-axis at -1. So it's be y equals -1. Okay. All right, so let's do one more, and then hopefully we'll understand what's going on. All right, so I have to flip to the back here. So let's say that we have f of x equals -1 over x plus 2, and then -1. Notice we got something different going on. So we're going to graph it like normal, and then I'll talk about what this little pesky negative does. All right. So the thing that's with the x, you do the opposite. So the opposite of this would be going left 2, and then that would move it up or down. So it'd move it down 1. Okay. So we're going to graph it like that. Remember, you move the asymptotes first. So draw my graph here. If I move left 2 and down 1, so left 2, down 1, it'd end up right there. That would be where my asymptotes cross now. So I'm going to draw my invisible lines so that we have at least something to go off of. And I'm going to draw a couple more things to be able to draw my graph here. So if there was nothing else going on, then remember, you'd graph it like normal. So I'm going to go right 1 and up 1 and put a little dot there. So I'm going to kind of lightly sketch it so it look like that. And then left 1 and down 1. And it looks something like that. Okay. Now, let's discuss what this negative does in the front. If you remember, if you're multiplying by a negative in the front of your function, that actually flips it vertically. Okay. So all we have to do from here, now that we have it kind of sketched, is it's almost like you take your graph and you flip it vertically. So this part right here is actually going to flip up. So it's going to flip up. And then this part right here is going to flip to the bottom. Okay. So think about flipping it like flipping it over like a pancake. Okay. So if I flip this one over, it's going to look, and actually let me draw my point. It would look like this. So there's that part. So notice you flipped it over. Okay. So I'm going to erase this. Okay. And then this part is going to flip down. So I'm going to go right 1, down 1, kind of do the opposite of what I did a second ago. And then it would get close to that, the asymptotes that way. Okay. So I'm going to erase this so that we know what our final answer is. All right. So that would be the graph of that. And then we just have to tell the equations of these asymptotes. So the vertical one, it crosses the x-axis at -2. So the vertical one would be x equals -2. And then the horizontal asymptote would be it crosses the y-axis at -1. So it'd be y equals -1. All right. So let me know if you have questions. Have a great day.